Hello, and welcome to our Group Project Design Lab number 2.
Today, we're going to be fixing the issues found in Design Lab number 1.
The overview for our project consists of a quick product overview explaining the product in minor details, the Design Lab 1 issues we were faced with, the solutions we proposed for those issues, the application of a just-in-time and Kaizen analyses, the results we got from those analyses, an economic analysis from those results, and we also summarized our product overview in detail. The measuring tape which our team is going to be constructing and distributing is an orange measuring tape sold by Canadian Tire. The measuring tape is sold for $4.99 and is 16 feet long and has a black stopper which allows for precision accuracy when measuring. The tape also has a white guide which allows the tape to move freely and smoothly.
The issues with Design Lab 1 included the inconsistency of the measuring tape's spring position, the handling and fastening of the screws, the white guide piece, and the quality of the process.
Possible solutions for Design Lab 1 consist of eliminating the need for the white guide on the tape, the addition of a screw dispenser for easy access to screws, the use of a drill to speed up the tedious task of hand screwing screws. Adding these can increase quality of production and output of the system.
Possible solutions for spring variability include a design change for easing the manufacturing process, assuming the cost of each unit increases to accommodate for each theoretical quality change, and the spring will be delivered and ready to be placed with a removable plastic piece so be easily disposed of. It was noted in Design Lab 1 that there may be some inconsistency with the placement of the spring after its rotation onto the base. To help decrease this inconsistency, white indication lines were added onto both the spring and the base to allow for a visual cue when lining up the two together.
Our team has decided to add a screw dispenser because in Workstation 3 and 4, screws can be hard to grab and can be very finicky. Using a screw dispenser saves time. The screw dispenser our team decided to use is a screw feeder which allows easy access for the screws to be placed onto the screwdriver. As you can see, the worker is able to easily apply screws to the driver and use them as needed. Using a screwdriver takes a long time and is very hard to use. The screwdriver can be very hard on the worker's wrist. Our team has decided to use a drill in place of the screwdriver. The drill is a more ergonomically friendly option. Not only does the drill save time, but it also saves money. The drill our team decided to use in place of the screwdriver is a 180-degree sealing tethered drill. The sealing tethered drill speeds up the screwing process and allows for fast-moving workstations. The drill includes a strap which allows it to not swing freely after its use. As you can see, the worker simply uses the drill and lets it go. The strap holds it in place until the next use. In Design Lab 1, implementing the white guide piece was a limiting factor in the time it took to build the tape. It was slow and awkward to place and just caused a slower workstation time. Our group decided it was best to completely eliminate the white guide piece in the construction of the measuring tape. The guide piece was determined to be relatively useless with respect to the design of the functionality of the tape.
Masaaki Imai, the developer of Kaizen, says it is the basic philosophical concepts underlying Japanese management, which includes just-in-time. This was widely implemented in Japan following the Second World War in order to compensate for their lack of inventory space and for their slow growth economy. Contrasting with innovation, large-scale major changes, the Kaizen philosophy represents constant, small improvements and maintenance over time of a system. Organizations following Kaizen implement it throughout, from factory workers who participate in group sessions and make suggestions to improve their daily tasks, to upper management that introduces and supports Kaizen systems. Not only do employees use Kaizen, but companies, customers, and suppliers do as well. This ensures the process, from receiving raw materials to exporting a product, is as synergistic as possible. Typically, in such a system as ours, being small scale, allows for workers to gain competence in other aspects of the production system. If ever there is a breakdown, idle time can be reduced as a result of several employees that understand more than just their own process to address the issue and come up with solutions. We assume our demand is constant. As it is constant, a just-in-time system is able to produce with minimal buffers. Changing demand would benefit from changing buffer sizes or even an expanded inventory system. This is a risk all just-in-time systems face. Because of the constant flow and generally smaller batch sizes when compared to Western production systems, 100% inspection is feasible. The reason just-in-time is questionable for large production systems is that it relies heavily on the flow of information. The larger the production system, the more time it takes to communicate issues down the line. Our small scale allows for information to be immediately communicated across employees that are also in close proximity. As our production demand is constant and small scale, just-in-time fits our process well. Furthermore, our rate of production means there is additional time at the end of production, before the end of the week, to compensate for any quality issues.
As you can see from our spreadsheet, there was a noticeable improvement from Design Lab 1 to Design Lab 2. From our calculated 95% confidence interval, we were given a time between about 12.8 to about 28.2. As you can see, all three of our tasks are in this confidence interval. The workstations decreased from 4 to 3. This is a great improvement from an employee manager point of view. Overall, we were faster, our quality was better, and it cost less for our group to construct the tapes.
RULA and economic analyses were performed on both design labs to quantify the improvements from Lab 1 to Lab 2. Our team determined that our upgraded lab was not only more efficient from an industrial standpoint, but from an ergonomic standpoint as well. As using a screwdriver all day would eventually become strenuous, on top of it being a slow process, it was obvious this was a task with room for improvement. In exchanging the screwdriver for a 180-degree drill that is tethered, we would remove the need to laboriously fasten. Instead, the hand can remain neutral and lower the tool rather than picking it up for every use. A RULA analysis supports this, going from a medium-risk activity in Lab 1 to a low-risk activity in Lab 2.
After coming up with a few possible solutions to the issues in Design Lab 1, the cost to implement these solutions was explored to get an idea of the payback period, as well as the total increase in weekly profits compared to our initial assembly line. Using a few base estimated assumptions for both labs, the weekly output of each setup was determined and scaled by the bottleneck workstation of our trial. Due to this fact, the amount of hours required by each employee can be scaled to hit the target of 6,000 without overproducing by a large margin, so that we are still respecting the ideas set by just-in-time and Kaizen practices. For the solution cost estimations we assumed for the increase in quality for the spring, it would incur a base increased cost of materials compared to Design Lab 1. For the implementation of the white guiding piece into the base, an R&D engineer was hired to design a prototype. To increase the performance of the workers handling screws, a vertical drill was installed, which would incur costs of around $250 for the ergonomic reasons mentioned previously, as well as 2 screw dispensers, which would incur costs of around $1,600 in total. Comparing the 2 projected weekly profits of both setups, and including the one-time fixed cost for the workstation upgrades, the difference between the 2 setups evens out at around 10 weeks in, where Design Lab 2 begins to pull ahead.
To summarize, in order to improve the process, several changes had to be made. These changes included the addition of a drill, a screw dispenser, and white indicator lines on the spring and the base, as well as the replacement of the white guide piece with a redesigned mold for the measuring tape.